Should we start? Okay. So before we start, so just a short poll. Who already used MySQL 8.0? Oh, guys. Who hear about MySQL 8.0? Fine, it's better. So do you know what kind? Okay. Do you know we have new redo log in 8.0? Ah, guys. Do you know we have resource groups? Okay, so you know more about resource groups, so fine. Because I have a challenge, I have to repeat you something, so what we already achieved, before to go to what is hot and where is the problem. So this is just a short page about me, so you can find all my articles, blogs, and so on. And here's about topic. So in fact, well, I saw there is many new people, so I cannot just move to the hot stuff we are working right now, but I need to tell you what already done and why MySQL 8.0 is so great. So also I wanted to compact my talk because there is 200 slides, but people complaining about them when I remove something, which was fun. So this is a fun stuff just to put you in ambience of MySQL performance. So why? Each is starting like this. Probably you will recognize your newly made new years of your application. It's really working, and then you hit your first performance problems. After what you realize you need something more serious, and even when you have serious, you did not realize and your load will be higher. And after all, it became worse and worse. And once you become really popular, then you have real problems, and then you have to face it. And even you develop something iron strong, so there is still stupid man which will destroy everything. If you saw on slides of Peter today, so it's probably more than half of errors, and you have it's just user errors and local errors, so from development and so on. Also, it's amazing because time to time, well, I'm tired of such kind of discussion and people saying that performance is not helping, everything is working alone, we don't need to care about. So this was a discussion with very academic guy, let's say, but a huge mind, okay? So saying that, okay, we don't need care about performance. So what about response time? And in fact, you see, if you have bad response time, nobody wants to deploy such a software. So we just come back to performance points. So it's like an entry ticket. If you don't have it, nobody wants what you do. And with MySQL, it's pretty particular, probably. Well, it's true for anything, but, well, for example, not true for Oracle database, let's say. But for MySQL, well, I will not torture you, but the main practice number one, use your brain. You need to think every time what you're doing, because as soon as you stop, you will miss something. So this is the main slide. You can skip everything. So, and especially, when I ask people what is your main performance problem, they say my developers. So it's even more fun. So that's why my problems, every answer you can find in documentation and manuals, whatever you can read. So it's not my problem because it's already explained it. You just missed it. So my main problem is everything which happened by design. So we cannot fix. There is no workaround, and we have big problems inside. Unfortunately, when we speak about benchmarks, it's always saying like, okay, Hoop is more far than others, but well, sometimes it's true. But in case of MySQL, it's completely different because it's every workload we have, it's a big pain problem for us. So when we solve it, so we are not running to, to show you big numbers or whatever. We're just solving problem after problem. It's, well, sometimes hardware guys are not happy with us because they deliver new machine and nothing happens better. So for every benchmark, you need to understand what happens inside. So well, you can see this II bench, it's insert benchmark, which is used for all storage engines which inserting fast. They want to show you they inserting fast and InnoDB inserting slow. And slow why? So in fact, the main problem is in InnoDB using B3, and B3 growing very quickly. So as soon as you cannot keep it in memory, you will read it from disk all the time. And as soon as you read from disk for every page, of course, you're going 10 times slower. So here is a short example. Just to show you, well, probably there is a little bit mixed on the graph, but you can see, so in fact, on the graph on the bottom, you can see the memory going down. So we have less buffer pool we have, quicker memory will go down. And then what happens, so we may have good performance on insert, but as soon as we don't have memory anymore, it will just going down every time. So what happens? It's just enough, then use partitions, and then you will have smaller indexes, smaller B3, and every time you switch to a new partition, you will not have this problem because it will be new B3 and it will be again in the memory. So what happens is, on the next slide, I just used partitions for this exactly the same test. Even if you have a small buffer pool, it will work well. So this is a point to keep in mind. For example, even when you're comparing to MyRocks, RocksDB, so you don't always need big memory. Even with small memory, you can do well. So the main question for all people, what kind of workload I have to test? What is specific for me? The only question we have is all production. If you can simulate your own production, it's your answer. It's exactly what you're looking for, what you want to optimize, and so on. So it's not easy. So you have tools, free tools, commercial tools, and so on. Well, if you don't know, you cannot simulate your workload, so use generic tools and share with us, because if we can reproduce it in QA and internally, it's a huge help. You don't need to start with something big, and it's amazing because more years passing, more people inventing something to test. Sometimes it's completely stupid. So you can start from something small because any big workload, it's just a collection of small tasks. So you should not ignore the case, but just divide them, and once something working well for you on the small things, you can go to something more complex. So to start with, so we have this number of tools. I will speak about this bench, which is entry ticket. It's most simple to install, most simple to use, and you have your result at once. And there are so many references, and you can compare your system if it's working as expected or not. TPCC is, most popular workload for databases. Then there is also HammerDB, and it's using storage procedures. Who is using storage procedures in production? Okay, guy. Well, it's efficient, but yeah. So if you want to test how your storage procedure is working, use HammerDB. You will see. I was surprised that the code was not changed since probably MySQL 5.1, but it's working extremely well. Still very efficient. So in all this stuff, some results I will show you. This is a real example. So there was a guy who complained because MySQL 8 is going slower, and his test case is he took just from DigitalOcean. And in fact, you can download, you install employee table, you run the test, concurrency 50. But well, what this test is doing? And this test is doing is just running 5 select star queries without where clause. So in fact, you have 5 full scan running concurrently by 50 users. Does it really match your production? Who is doing this? The guy doing this in production should be fired, right? So a guy testing this without looking, okay, and 8.0 is slower. So I tested, no, it's not slower, it's even faster than 5.7. So he just even more doing something stupid, but well, that's why the rule number 1, think about what's running, what you're doing. The same stuff you can do with this bench. So in fact, it's extremely more simple to use now. It's more efficient. So the main worry in the past was that it's using Lua scripting, and it's not as fast as normal binary. In fact, it is fast. And just to give you an example, for example, if you want to run whatever query, simulate whatever workload, this is the most simple script. So in fact, what happens here is connection. Then when you end, it's disconnection. And here is your query. So you can run whatever kind of query you want, and in 5 minutes, you simulated your workload. That's all. So it's extremely simple and extremely efficient. Now, so as you did not hear so much about, this is probably your slide. It's how our improvement was going in scalability mainly. So in 8.0, our main target was about, because writes are still not scaling in MySQL, and in 5.7 reads were not scaling, so we are progressing. It's still not perfect, but it's way much better than it was before. So, as you don't know, and I will tell you, so every time when you see Flame, if something good happens, so this is good, and we can do more than 2 million queries per second. It's on point select, it's just primary key lookup, okay? So what's amazing, then you see this was yet 2 years ago, and it was 4-socket 96 cores machine. And next year there was Skylake coming. And now, mostly with 2 CPU sockets, we are able to reach the same performance. So it's 2 CPU sockets, not 2 million, but 1 million to 8. Well, and with some optimization, it's still 2 millions as well. What's amazing is, and there is new CPU also came after Skylake, is Code Lake, no, Cascade Lake, oh, don't recall the next one. And it's supposed to be faster, but it's not faster. So this is another mystery which I'm trying to resolve right now. And it's not only about reads pure, so it was read with Latin 1. There is also improvement in UTF-8. So UTF-8 was a big madness in MySQL historically, and it got improved exactly in 8.0. If you need to use UTF-8, it's the way to go. So the difference is huge here. Well, and especially from where difference is coming. It's not coming, so like if we will look on point select, there is mostly no difference, because when you do lookup on primary key, you don't do any comparison. But if you do any comparison of variables, so if you do group by, sort by, and so on, the difference is huge. Well, do you recall that MariaDB claimed that they have huge performance improvement? Well, you can see it here, right? So, I will just mention you, then we also, there was a huge just global lock about all IO reads in UniDB, which is solved in 8.0. We can do 1 million IO bound reads, so it's 1 million queries from storage for the same lookup. So it's extremely heavy because you touch storage, it will be latency and so on, so it's obtained on Obtain. I just give you a link with detailed explanation to make shorter my log, because there is a lot of stuff to tell you later. Whoa. So we started to change internals, and this is my question about, we have new redo log in 8.0. We will have also other stuff, log management, transaction management new. It's in progress, but it should be production stable. So we have prototype for the moment only. And about redo log, so before there was just a global log for all users. In 8.0, you have totally parallel writing on redo log. So users are not blocked anymore. We are going to full speed. It's full speed of your storage. Redo log is working on full speed of your storage today. Also, there was some improvement internally. So during proxy SQL talk, for example, people asking if do we have already CPU usage measurement? It's made already in redo log stats. So you can see a lot of information inside. The main problem was, as it's multi-threaded now, so what to do when we have only single user? So single user doing alone everything, and we have 4 threads doing the same in parallel. Synchronization is not for free, and it's not going fast. So there was a dilemma how we have to do. And well, this from the past was kind of famous slide, because you can see all these graphs and all different strategies giving you different results. So right now we have the new version which is coming, which will work on low load, it will work like before. It will be only one thread working. And when you have more users, and it will working with multi-thread, and it will be more efficient. So you can see that. Where is? No. Okay. So because this is probably, if it's not seen, you see it's a different strategy. So you can go up and go down just because the strategy is wrong. So it was all about spinning. Should we spin or not? And spinning is most efficient. And events management is not efficient. So it was many surprises implemented here. Because of this, we were able to deliver 45,000 on OLTP read write, sysbench. So again, well, you see MariaDB there as well. And the most fight was also about the excessive writes. So when your database is bombarded with updates, it was a huge problem before. So first we lose performance in 5.7, so it was a huge win in 8.0. So MariaDB moved to InnoDB from 5.7. They have exactly the same. They have worse result than 5.7 itself, so they lost everything inside. So now they claim they have something new, so let's see. Now, I mentioned use and we don't have, so our writes are not scaling well. We are still, why on OLTP read write we have better results on many CPU sockets? Just because we have reads. If you have aggressive writes, it's not scaling. So this is one of the reasons, and we have resource groups. So I will just bypass the details. So what resource groups are doing? You can just bind your queries to a given list of CPU cores and protect your workload generally. So you can lower priority for them. So it will be lower thread priority. For example, you can run your alter table index creation on lower priority to not impact others, or anything else. So here is a live example about, so writes are not scaling, but reads are scaling well. So reads alone working well, writes alone working well. When we mix them together, they starting to fight for resources. And here is the example, so it's running, sorry, here. Examples, and you're starting to have, we will try to just to limit writes to a given number of cores and leave reads running as they run. So here is the result. You see the blue line is what happens by default. So if you don't use resource groups, your reads, you know, it's starting from here, and more writes you have, it's going down, 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 down. You see, and you're going too low. So if you use resource groups, you have exactly this line. Okay, and it's protecting all your production from any unexpected stuff. So, well, this is just a point to show you difference. Wow, so this was about what is done, okay? Now we are going to what is hot, and where we have a headache for today. So, to summarize, from 5.7 to 8.0, on read-only, we have problems on block logs and so on. So you can use proxy SQL query cache, look up for secondary indexes. You may still manage to use primary key. UTF-8 use 8.0. Global IO reads, lock-on IO reads is also fixed on 8.0. And on writes, there is a huge list of problems. So fortunately, we are since 8.0, we are on continuous release. So we deliver new features. With every update, you will see new features coming. So redo log is already came, double write is coming, will come soon. All other stuff in work, so update performance is improved. And for push, like at least we have solutions you can truncate. Before there was no truncate at all. So for insert performance, well, you have the story about partitions. Now, okay, let's go to most painful stuff. So binlog sucks. I hate this stuff. You cannot imagine how, but and yeah. So as soon as you enable binlog, you lose everything. So in fact, well, it's like well, you know, we are always going back in 20 years ago, and people thinking that the problem started since 8.0. No, it's also top graph is 8.0. Bottom graph is 5.7, the same story. And when people asking, will I improve performance if I move my redo logs on very fast flash device? in this test, so the first result is binlog is just not writing anymore. So just presence of binlog is kill all your performance. So will it be fixed one day or not? I don't know. So probably we'll find alternate solution or something this, but well, we need to do something. So Sunny told you then you can use, if you follow InnoDB stuff, then you can use InnoDB truncate, undo truncate, which is automated by default today. You may get this kind of surprise. So this is a surprise when, so on the left side it's disabled by well, not by default, just disabled intentionally. On the right side it's enabled. So if in your production you see such kind of problem, ping Sunny directly and send him email because, well, initially he was thinking that it's Dimitri invented something. Now we can start to see it in many tests. So I hope it will be fixed one day. But, well, at least you have a workaround. You disabled it, you can always truncate your undo. It's not a problem. You know, as soon as you have workaround, it's not a problem. This is a real problem. So we have new redo log, which is writing faster. So now if you have slow disk, so your redo log may always writing faster than you flash your data, and you will be always hitting no space on redo log. And you see this is amazing because once the problem is coming, when the problem is coming, so even you see the load is going up and down here, nothing changed. Once you hit the problem, it's a problem. The fix is coming in next update, so it's already validated. It's all okay, everything working like we need, so you will see it, and it's continuous release, so it's excellent. Now, the most painful stuff. Small hardware. So, you know, our problem was the code was always slower than hardware. So, of course, some people buying big machine and complaining, oh, we spend 1 million and you have a bullshit from MySQL. So we wanted to see it working. But today with cloud and all this story, you have small hardware as well. And if historically we saw only regression on on single thread performance, now we started to see it on high load. And this is amazing. So this is OLTP read-only, so just read-only queries. And if you follow the yellow line, you can see that MySQL 8 is okay, it's going down on one thread. So on the top, okay. Why it's hidden? Okay. So this is 1, 2, so 1, 2, 4, 8 threads. And it's already going down, and here it's on high load. You see that MySQL 8.0 is already down. On point select, it's even more impressive. So you see, especially, we are here with MySQL 8.0. Lower than 5.7, lower than 5.6, and so on. So this was a big surprise. So on reads, and especially there is nothing to be blocked, so everything is scaling. So everyone thinking the problem is about code path, because more features we have, more longer code path became. So on read-write, as soon we have writes and we improved writes in 8.0, the problem is lower. Well, it's still thin, but it's not low. It's smaller. So on the low load, it's still okay. So we are just losing on high load. And on update, it's amazing. So on update, well, it's what we expected to see. So you can see then it's higher. So 8.0 is doing better. And even on single thread, it's still okay. But then, okay, you have some problems on high load. So what is the problem? In fact, the problem is not about code path. The problem is about how the code of threads is compacted. So in fact, our code is now so big that we constantly have instruction cache miss. So it should be, our binary should be optimized in another way. And this is the most amazing stuff, probably. So you see it's just used two different levels of optimization on binaries. So, well, on OLTP read-only, so there was a regression, but on point select, it was much more impressive. And you can see then, so it's green and orange line are optimized binary. You see, comparing to 8 to yellow graph, so how huge the difference here. And just because the binary is not compacted. So this is optimized binary, is going far. So if you read the blog post from Vadim, who complained that 8.0 is not always faster, I sent him the optimized binary. He tested, he saw that it's better, but he did not publish it. So it's classic Vadim, you know. Let's complain and then, okay, Percona is the best, right? So this is point select. Now it's about read-write. So again, there was no problem on low load, but you can see then, well, here we are going higher with optimized binary in 8.0. And pretty interesting story on updates. So on update, it was already better, but it's even more better on high load. But it's amazing, you see then 5.6 is really bad on low load, but something came in the code which make it broken. So in fact, well, in 8.0 is better, we have new contentions to fix because we fixed redo log, which make other contentions more hot. So transaction contention, log contention, log management is killing now this performance. So once it will be fixed, I think, so in our prototype, you know, we got, I don't know, 400, probably 1,000 update per second, so it was bigger numbers than we ever seen. Right now we are on 250,000. Okay, this was about low. Now about double write. Double write, it's so crazy problem. So in fact, what is the problem? Why double write is a problem? So in fact, you cannot protect today your pages write from corruption. So Linux still has no atomic writes. So you cannot guarantee. So even they claim that, okay, 4K writes can be atomic. Well, I still don't believe because there is many levels on Linux and it's not atomic. And InnoDB writing by default with 16K. So with 16K, there is many chances and your write will not be finished correctly. So to protect it from corruption, we write on the page twice. So one, it's writing in dedicated place, which is double write, and another on the data file. So what is the problem here? It's, as we write in twice, so your page write latency is doubled. So if it was, I don't know, 2 milliseconds, so it will be at least 4. And generally it will be 5, 10, or whatever. So it depends how working is your storage and how efficient you are. So that's why if you have good storage and you can write more in parallel, you can hide this because you write more pages, so okay, it's taking 2 times longer, but you write more, and in parallel you still write the same amount, so it will be okay. And in background you will not see it. So if all your data are in memory, you will even not see impact from double write. The problem is if you have I/O bound, so you will read from the storage, and this is the problem. So before you want to read, okay, so you need to bring your page in buffer pool. To bring it to buffer pool, you need to have a free page. If you don't have free page anymore, you need to flash something, so evict a page. And if all pages are dirty, so your read will wait for write. And if now with double write it will be twice longer, 10 times longer, then of course your reads will block you and everything is blocked. So that's why on I/O bound, the impact is much more bigger. So, and especially in the old design, there was just a big lock. Well, what is good, then you can see it only on high load. You will not see on low load. But well, it was evident that we have to fix it. So Percona delivered double write in their Percona server 5.7. So in our case, our code was ready before we delivered MySQL 5.7. But the time was shifted for GA, and it was just not ready for GA. And in 5.7, we did not use continuous release. So as it was not continuous, once GA is announced, so no changes coming. So to deliver this code in 8.0, it was a long story. So finally it was available, well, the first version in August. But, so it was ready to be pushed, and it was final testing just for the latest kernel, biggest machine, and so on. And then the story started to be fun. So in fact, we started to discover so many new problems. So hope you will have this fun with me as well. So this is a TPCC 1000 work data warehouses test on small machine, 12 cores, okay? So on the top, we see double write disabled. On the bottom, double write enabled. So I love Percona, right? But this is result from Percona. So in fact, Percona is supposed to be better, but they are worse. And MySQL 8.0, which is supposed to be very bad, it's better than everybody. So this started, you know, it started our first headache. So what happens inside? Then I understood then, okay, something, we have a problem with, it was ext4. Let's test XFS because, and this is amazing. The story is different. So if you know, if I will switch, you will probably see the difference. You see? ext4, XFS, ext4, XFS, ext4, XFS. So it's like moon and sun, but, well, slightly opposite. But again, so I was surprised and Percona, which was already good with their double write, well, okay, we developed a better version, okay? Well, just between us, learning us. No. Well, but anyway, the problem is a problem. So why? So we started to dig more. And so what we discovered, shades. And so before we used kernel 4.1, so this is without double write at all, just ext4. And new kernels which come in, so kernel 4.14 and new one, kernel 5 and so on, double regression on the file system. So well, then I really understand Oracle database. They move it, they don't use file systems, they use their ASM and they bypass all these problems. We are digging this right now. And yet more worse, so this is ext4, so of course with double write it's even worse. But the most amazing is with XFS. So in fact, with double write disabled, ext4 doing better. With double write enabled, XFS is doing better. But XFS is doing better when it has double write enabled comparing to double write disabled. So when we write more, we are going faster. Can you believe this? But I have the test case which is proving this shit. And we are, so right now we are fighting with Oracle Linux guy, storage guy. So in fact, you see it when you have fast storage. If your storage is slow, everything's okay. With double write, you're going slower as expected. As soon as your storage is fast, so this was obtained, and then we use it fast SSD, it's a total mess. No explanation what happened. So well, there was guru guys from XFS asking me to collect all block traces and so what? Nothing. So no explanation, no, well, I'm starting to suspect everything here. So let's see. So that's why you don't see double write right now. So because on, well, it's a main problem was double on IO bound. So we expect it's not yet hot for you too, but we will fix it and deliver a new version. Now, the most famous topic probably. This is about TPCC. So last year, I will bypass the story. So we have several TPCC versions. So it was DBT2, TPCC-like, developed by Percona. Then Percona guys moved it to Sysbench. It's proven like on new Sysbench you can develop whatever you want. And there is HammerDB with storage procedures. But so in the past I used DBT2 and TPCC-like from Percona just to have two tests about the same story, so TPCC. And my big surprise was okay, once it became much more simple to use TPCC-like since it was on Sysbench, but it was not scaling. So on one CPU socket, you have exactly the same performance as on two. So here is it one, Here it is 2. Well, I don't know if you probably understood. So all these graphs are going the same way. So it's from left to right. It's from 1 user to 1,000 users. So load is growing as it's going down. And so my curiosity about this was then on TPCC-like, so 6-bench TPCC, it's not scaling, but the same volume of data given twice better performance on DBT2. And this was a headache. So on 6-bench TPCC, we have index log contention, and on DBT2, we don't have it all. How it's possible? So while I started to our guys from Percona is delivered the tool, so you should be curious. So Vadim tell me, well, because on this new version, you can use many databases in parallel, so data set. And of course, if instead of 1 table, we have 10 tables, your index log contention will be splitted by 10 tables. It's 10 times lower, and you're going faster, fine. We just found the way to hide the problem. But the problem is here. So the main motivation here was for me, so even if we cannot fix this shitty index log contention, if we'll find why on DBT2 it's absent, we can propose a solution to users, to bypass it. So probably there is something in the code. So well, I spent tough days, to analyze where is the difference, probably foreign key, not foreign key, or for update or not for update, some locking of something is protecting. Well, and it was amazing. So when I discussed it with Percona guys, so especially the guy who worked before, so his code name is Ranger, but it's Alexei Stroganov. So he worked at MySQL before and used DBT2 all the time. So now in Percona, he loves, in the past, he loved DBT2 a lot. And he started to test so official DBT2. And so, what the fuck, who changes the schema? Nobody changed it, I know. And then we discovered, so there was a changes in schema, and for a new order, in fact, the table of new order in the data value was changed. It cannot be null, but by TPCC standard. So when you have a new order and it's not delivered, it will be null on place of data. And as column has condition not null, it was just rejected. So in fact, half of transaction were rejected. We get rollbacks. And of course, we don't have index log contention because it was totally wrong. So while I used this magic tool like a block box, in fact, I discovered, okay, we have a problem. So now it's fixed. Well, I don't know, but we know why we have the problem. The mystery remained why we have index log and can we fix it or not. And then what's fun, and Yasufumi came back. So he was at Percona. He was in our team. So then he wanted to do some other stuff. And now he came back again. And he started to dig it. So it was his welcome project. So he took it seriously. And in fact, he found why we have. So the index log is coming because we have a massive page split. A massive page split we have because TPC see exactly inserting null value, okay? And later it will be updated to something real. Of course, when you inserted null and then you want to update to something big, there is no place anymore in the page. And that's why you have split of pages, massive split of pages, and so on. So what is the solution? So we have an excellent workaround right now. So instead of null, you can just decide that we have default value. And this default value can be of size, your average size or exactly size and you want to use. And you see, in MySQL, you already have all solutions for this. So instead of null, when you insert them, you can say default. Especially why it's good, because it's related to database. You don't need to change your application code. So you just decide the default, I don't know, today it's 0, tomorrow it's 25, whatever else. But your code will insert default, it will be default. And you can compare to default when your workloads, just straightforward. So instead of null, you use default and you solve this problem completely. And we will have final solution, which will be in the code, which will, well, this will solve your page management, but well, my feelings, and it will be much more simple to use default than predict how many space you will need in the page. It's not a simple story. But default is extremely simple. Now to show you the difference. Null on the left side, default on the right. Yes, you see more than twice higher performance. And this is so you can obtain exactly the same story in production. So what is good, and in new code, we'll have instrumentation reported all these pessimistic splits and blah, 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 all everything around. You will know exactly which table and which table you have problems, and you can correlate it with your query, and understand which query is making you page split and improve it largely. So now, to compare apples to apples, this is with default. So you see, it's so this is one data set, so it's 1,000 warehouses. Well, if you don't see where is 8.0, let me show you again. It's okay, the better line on the top. So Percona has all reasons to be based on MySQL 8.0, right? So it's just on the same line. MariaDB, no comments. Well, they say they have best performance. So it's. And here I also, well, by accident, let's say, but I tested, in test came Percona server also 5.7. So, and you can see then, okay, 5.7 story is here, you see, and 8.0, so everything which is based on 8.0, it's here. Or MariaDB is here, or no words. So, well, good reason for Percona, right, to be based on MySQL 8.0. And how to say it, cherry on the cake, whatever you want. So this is a story about DB stress. So in the past, I used this workload a lot. And it was suspended a little bit because for all the problems we have before 8.0, it was too complex, in fact. So every time I tried to use it, I just killed MySQL server, so it was fine. And the mystery about this, so you have, I show you that on point select, we have 2 million, right, queries per second. So on all Peridot mixed, we have a better result. We have ranges and so on. Here you have select one, which is doing join from 3 tables. And then you have select 2, which is just doing join from 2 tables, okay? And the select 2 is not scaling at all. So this is amazing. So this is select 1. So what I saw what is helping. So by default, in select 2, it's secondary index used, okay? So select 1 scaling, nothing to do. Select 2. So if I use so this is with secondary indexes, and let me do red line. This will be with primary key. So you have pretty significant speed up if you use primary key. The problem is it's not solving you from scalability, because on the right side is 2 CPU socket, and it's still slower. Okay, primary key on the right, so you see this is primary key, is still doing better than secondary key. But it's lower than on the left side. And this read-only. So we are hitting some hidden problems, which is definitely related to CPU cache, and it's horrible. There is no way to understand this. It's, so we are working with Intel guys, with Oracle Linux guys to understand what can we do, how we can detect, because this is painful. When if you don't compare, you even don't know, then you have a problem. So this, again, a good example for you to use resource groups. So because if you see, we will leave it, all these queries running on one CPU socket, you have higher performance if you leave the whole machine for them. Just straightforward. Now, when they're mixed together, so select 1 and select 2, it's amazing. So we have higher performance, but again, it's not scaling. So it's not scaling on if we have one single data set. So it's just, well, one table for everything. So there are many tables, well, 5 tables, but single data set. Or we have 10 data sets running in parallel. And in this case, you see, there is a gain, especially when you use primary key. But again, it's just hide the problem. It's not solving it. And now if everything is mixed and also with read-write, then okay, we have, again, so we have higher performance if we use 10 data set. But the most interesting, look here, it's which color? This part. So if we use secondary key, there is no primary key on the table. So InnoDB will create some hidden primary key, and then you have a big trouble because something going badly, and we totally lose our processing. So it's just stuck and nothing happens. All sessions waiting for something or some internal logs. To understand what happened, well, we will need to dig it. So, well, it's nothing reported by InnoDB, nothing special reported by system. So, but now if let's take all this together, and you know, it's like everything in this life, everything is relative. Shit. Everything is bad, not scaling, blah, blah, blah. You know, Dimitri told us bullshit, look on this nice graph. Yeah. So it's, you see, so MySQL 8.0 is still better than anybody. So every version we delivered until now, they are worse. Okay, and this is one data set, so 10 millions. And here is 10 data set. So you see the difference? Well, once we will fix this hidden problem on select 2, I think we will go even more far. And again, to say how much is different, it's relative. So I have this final slide, which will bring us 10 years in back. And this is the same DB stress test, but 10 years ago. And it was only a little bit more than 7,000 TPS. And now it's 95,000. So more than 10 times better result, and well, 10 years of history. Of course, there is a hardware as well and so on, but code, I don't know if you know, so in the past, we could not use no more than 2 CPU cores. Okay, 4 CPU, it was the biggest machines that we can use. And at that time, it was already 64 CPU machines, 96 CPU, well, big monsters and so on. So that's why 8.0, well, you hear about it, now you see then how it's great, so you must use it from this evening, right? So just download it, test it, and do your fun. So because there is yet more fun is coming, and a lot of stuff is coming. It's continuous release. Every time we deliver something new. Thank you. So if you have any questions, and also the last slide. Yeah. No, it's, well, I don't like this bullshit, but I will say you machine learning, right? It's so famous right now, but well, it's a common approach to every database code. We need to, the binary need to be trained and need to be optimized. So it will be public. So right now we have just results before, well, ahead of everything, but we will deliver the bundle, you know, then anybody can optimize binary, look what happens and so on. Yeah. So this is, if you want, well, all the graph I built with my tool, so this is a tool, so if you want to use it, it's free, like air. Any other question? Okay, so I think we were late because of award, so it's next talk.